Hello, this video is to help you with a few of your problems in the packet that Mr. Hill and I covered toward the end of the year about the derivative. Just to clear up what the derivative is. A derivative is the slope of a tangent line to a curve, and it shows the rate of growth at an instant. It's like magic. It is like what I told my classes, and that usually you need 2 points to get a slope, but the word I use is actually, that's crummy. That is not really indicative of what's going on at this red point right here, where my graph is decreasing. And so what we want to do is move closer and closer and closer. And so if we really want to know what's going on at this point right here, we want the slope actually at one point. And so what we do is we move this point infinitely close so that we can actually do some magic where we actually find the slope at one point, which seems physically impossible because you really need 2 points to find the slope. Slope, you've talked about only with lines up until this point, but obviously lots of things have slopes. So now we're talking about slopes, and the slope is changing, so unless it's a line. And so many times, almost always now, your equation for slope is going to have a variable in it. And there will be lots of things you've got to draw between those things, the facts that you've got to come to based on all of that. So anyway, we're going to be basing it on the slope formula, where you have y2 minus y1 over x2 minus x1. So just to reiterate something I showed in Honors Pre-Cal, like if I want to know what's going on at that point right there, and I use this point way over here, I'm not going to have any idea what's going on. In fact, this looks like it's going kind of down at a slow level. If I'm really far away from it, I have no idea. So if something's happened like in the city and I want to know about it, and I'm over on the east side and it happened on the west side or downtown, in order to really find out what happened, I need to get closer and closer and closer and closer and closer and closer, or better yet, be the person it happened to. And then I know the full story of what's going on at that point. And so as we move this around, we move further away, we don't know what's happening. So this starts off as 2 points, and then we move it infinitely close with our, almost our magic wand, the limit symbol. All right, so what we want to do is think about the graph like a graph like this. If I have a point here, let's call this x. So this would be x f of x. I'm going to move some distance away, and they call that h typically. So here's x, and I'm going to move out here somewhere a distance of h, and so this is whatever x plus h is. Like for instance, if x is 1 and h is 4, then I would be at 5. So this point would be new point x plus h, f of x plus h. And so I'm going to find the equation of the secant line. Now secant and tangent really mean locally. Like for instance, this is a tangent line right here at this point, but obviously it's going to hit it later, but that's not what we're talking about. So when I'm talking about a secant line, you're used to it maybe just hitting in 2 places, and we're talking about around here, not what happens way over here, which we're not even talking about. All right, so anyway, we have these 2 points, x, f of x, and a point on on one side of it, x plus h, f of x plus h. And now I'm going to write the equation for the slope formula here. So I'm going to say y2 minus y1, this y minus this y, and this x minus this x. So I have f of x plus h minus f of x. My x's cancel, and of course I have over h. The difference in my 2 x's should be the gap between them, which is h. Now this right now is just still the average slope that you've always found. and who wants to be average. Okay, so none of us do, or you wouldn't have signed up for BC. But the average slope between 2 points could not at all tell you what's happening as you move closer and closer and closer and closer and find the slope, not between these two or these two or these two or these two. We move this point basically into that point right there. So right now this is just y minus y over x minus x. And let's go, we'll stay on this side for just a second. And then we'll go to the next one. Alright, so using this, what we're going to do is say this is y, the difference in my y's, rate of change, and the difference in my x's, which just gives me this. And then I take the limit as h as that gap closes. And this gap, we want this h to move closer and closer and closer. We want this to move closer to this. We don't want the gap to be 4. We want the gap to be maybe 3, 2, 1. We definitely want the gap between them, h, to be 0. We don't want this point and this point to be any far apart. We want them to be microscopically far apart to where you're talking about the same point, so that you know the slope of what's happening at that graph. And so as soon as you do this, you've moved away from the average slope to the instant slope. And somewhere along the way, they name that the derivative, f prime of x, y prime, dy dx. All of these mean the same thing. Dy with respect to x. This all means slope, but it means at an instant, and it's called the derivative. And so here's our formula for the derivative. Okay. All right, so then we've got some summer work to do on that. And so I'm going to be doing 2 of them. Sometimes you need a conjugate, sometimes you need a common denominator, sometimes you need binomial theorem, or if you don't want to do a lot of FOIL. But I'm going to do kind of the techniques you have for verifying identities. I'm going to do 50 and 52 out of your summer work. So instead of just doing examples for you, I'm going to actually do some of your problems. And so I'm copying these down on my tablet right now, and you can add them to your summer work. F of x is 3 over x minus 4. All right, so right now we're going to be doing number 50. Okay, so what I'm going to do is I'm going to follow, this is y minus y, a function at x and a function at a point away from x, over the difference between the two, and then I'm going to take the limit. You want this gap between them, which is h, to get closer and closer to 0, and then you have the derivative. So I'm going to say, and you have to write down the limit every time until you've taken it. The limit as h approaches 0. Alright, so I would suggest you do f of x plus h and put a break in parentheses minus f of x all over h. And the reason I suggest that you go in and write it all the way out, sorry, I was trying to move that out of the way, so I'll just kind of circle this. That's my formula. And now I'm filling into it. So let me undo. Okay, so now I'm going to actually fill into this formula for the derivative. There's a few other formulas for derivative, but this is the most standard definition of derivative. We'll do the alternate form before we go. Alright, so I'm going to say the limit as h approaches 0, and I'm going to do f of x plus h minus f of x all over h. I do this so I won't forget my minus sign. It distributes to the whole thing, and sometimes you can get lost in what you're doing, so I like to write it all down at first. So I'm going to have 3 over, everywhere there's an x, I'm going to put in x plus h, and then minus f of x over h. Now I want to figure out what the common denominator is of this complex fraction, and I want to get rid of that most complicated part. So I'm going to take 3 over x plus h minus 4 minus 3 over x minus 4 over h. I'm going to multiply the top and the bottom by the common denominator, which is x plus h minus 4 times x minus 4. And if I do it to the top, I have to do it to the bottom. Now, if I tried to take the limit at any point right now, as soon as I fill in 0 for h, I would get 0 over 0, which is one of our 7 indeterminate forms that means to keep on looking. And still at this point, I would get 0 over 0 if you stop and check it. Alright, now on the bottom, when I've multiplied by something that I'm not trying to fix, like right now I'm not trying to fix the bottom, I don't do that FOIL. You'll be wasting your time. So I just write it out in factored form because I'm looking for something to cancel. Now, I need to distribute all of this here and here to get rid of my problem. So when I multiply times this one, these x plus h minus 4's cancel. And so I'll have 3 times x minus 4. Because once again, when I multiplied all of this over here, these canceled, and I had 3 times x minus 4. Now, I'm undoing it because then I've got to multiply it to this one also, in which case the x minus 4's cancel. I always have to watch out for this scary minus sign. So this is 3 times x plus h minus 4. If you try to fill in h approaches 0, you'll still be getting 0 over 0, which means you still don't have an answer. You're still looking to see if it has a limit. So now I'm going to take the limit. Take the limit as h approaches 0. I'm going to distribute 3x minus 12 minus 3x minus 3h plus 12. I've left this factored for a reason. You'll do all sorts of techniques that you learn like when you're verifying identities. And yet still, if I fill in h is approaching 0, if I put in a 0 where there's an h, I'll get 0 over 0. If you've done this right, though, a bunch of stuff should collapse. These cancel, and these cancel. And the only thing left here is negative 3h over h times x plus h minus 4. Excuse me, my husband and I are both sneezing. X minus 4. And I'm going to take the limit as h approaches 0 because I haven't done that part yet. These now cancel. And now I'm finally able to fill in 0 for h. The top is negative 3. If I put in 0 for h right here, I get x minus 4 times x minus 4. So I get x minus 4 squared. That means my derivative is negative 3 over x minus 4 squared. Some things to think about here. What should happen to my derivative at 4? The slope should be undefined. What should happen to my derivative whenever it's not 4? I have a negative 3 over something squared, and so it will be going down most of the time. Let's look at a graph of this and look at the slopes of the tangent lines at different points. So I'm going to put in 3 divided by x minus 4. And let's look at the slope of the tangent line at 4. Do you see as I get closer and closer to 4, this tangent line is going to become, I need this point over here. There. This tangent line is going to become undefined at 4. It's going to be vertical if I could get as close as I could to it. You see the whole graph is undefined at 4. Also, all of my slopes, everywhere that I look, of these tangent lines, which I'm having to try to get these 2 points together, sorry. But anyway, the slopes are going to always be negative, which is what my derivative is showing me. The slopes along here are going to always be negative. Let's see if I can move this over here. These slopes are going to always be negative. Just kind of ignore the purple line for now that that's not doing anything. Let me see if I can turn that purple line off. Okay, so these, well, I thought I did. Alright, so as I move along, the slope of the tangent line at a certain point is going to be negative all the way. These aren't really tangent lines since I don't have this point right here that I move closer on the graph. I think I turned something off that I really need. Let me show you what I mean. So. Not sure. We'll see if this okay, so this is doing what I want it to. I'm going to put in a different equation, but here's tangent lines happening at a different point. So we should get a variable for our derivative. In this case, though, our equation was 3 over x minus 4. And so the derivative at 4 is undefined. The slope of a vertical line is undefined. But the slopes at all of these other points, you can see, are negative. They tend more towards 0, though. Let's see if I can get over here. I'm not sure how this application works, sorry. Let's see. But as I move along this curve, the slopes of the tangent lines should tend more and more towards 0, even though they're negative. So the reason I'm saying that is if you put in bigger numbers for x, like 7 minus 4 is 3 squared, 100 minus 4 is 96 squared, this is going to gravitate more and more toward a level tangent line as this moves out this way. Let me hit refresh so I can get back to that tangent line. Sorry. Okay, so anyway, you can see as it moves along toward 4, it gets to be a steeper negative. Away from 4, it's a flattened out negative. And we'll talk about all of that in class also. All right, now let's make sure we answered the question. Use the definition of derivative to find the derivative. All right, so we just did. So the derivative of this is right here. And so it's got a variable in it because it's the slope of the tangent line at whatever point I want to fill in when asked to do it. All right, so without all that explanation, let's go on to number 52. Right, on 52, all right, we have x cubed plus 2x squared minus x plus 4. All right, so it's going to be tedious, but I'm going to do f of x plus h minus f of x over h. That's just what I call the crummy slope or the average slope, and take the limit as h approaches 0. So I'm going to write it all down first. What I suggest that you do is first think of f of x plus h minus f of x. You remember to distribute your negative sign over h. Unfortunately, everywhere there's an x, I have to put in x plus h at first. X, the moved point. Always be careful of your minus signs. And then minus f of x. You always want to be careful in calculus that you copy the problem down correctly. You'll see that as time goes on, and be really careful with your algebra. So now I have the limit as h approaches 0. I'm going to use the binomial theorem or Pascal's triangle to do this. That's x cubed plus 3x squared h plus 3x h squared plus h cubed. This is 2 times x plus h squared is x squared plus 2xh plus h squared minus both of these plus 4 minus 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 a negative all over h. If you've done it right, everything without an h in it should collapse or cancel out. We'll see what I have now. X cubed plus 3x squared h plus 3x h squared plus h cubed plus 2x squared plus 4xh plus 2h squared minus x minus h plus 4 minus x cubed minus 2x squared plus x minus 4. Get used to lots of algebra and calculus. Alright, so now oh, by the way, every time I try to fill in 0 for h, I would be getting 0 over 0. So that means I need to keep looking. Alright, so these cancel. And these cancel. And these cancel. And minus 4 and plus 4 cancel. So I have 3x squared h. I'm going to go in and factor out an h. 3x h squared, but I've already factored out an h. H cubed, but I've already factored out an h. 4x times the h I've already factored out, plus 2h squared, so it'll be 2h because of this h out here, minus 1. You can see that little h buried in there, over h. I wanted to go in and factor it out because I knew it would cancel, and now I'm finally able to fill in 0 for h. Until you make this move right here, all of this is just the slope between any 2 points that could be far apart. As soon as you do this, you're moving the points closer and closer and closer together until they're 1 point and not 2. So when h is 0, it knocks these out, and so my derivative is 3x squared plus 4x minus 1. And so 52, yes, that's the correct answer. Alright, so that's the definition of derivative. There's an alternate form that I'm also going to introduce you to. And so to help you with the square root, you can do the same, not the same thing, but something similar on 51. Let's do 45. Now it wants me to just not find the slope of the tangent line, which is the derivative. This is called the alternate form of the derivative. Sometimes you see it with an A instead of a C, but they want me to do it at a certain point. But I encourage you to wait and fill in that point at the end, okay? So let me write this down. Sure, I'm getting more pages. All right, so we're doing 45. All right, 45 is f of x, or y, is equal to the square root of x plus 6, and we have the point 33. I'm going to ignore that. You can do it with the point, sort of, but I'm going to wait. I usually take the derivative and then fill it in. All right, now I could work this with this formula, where I have 2 points, and I name the gap between them h. But so here we are. There's one method that I've already taught you, or that Mr. Hill taught you, that I went over today, is if this is x and this distance is h, then this is x plus h, and you have your 2 points named this way. F of x is at x, and f of x plus h is at x plus h. So we've named our 2 points and the gap between them. Another method is we have 2 points on some sort of curve, and we call this x, and we just never say how far apart they are. We never call anything h. We just name the other point c or a. You'll get used to that. We use those letters a lot in calculus for like another variable. Alright, so this is x, f of x, and this is c, f of c. So I'm going to find the slope, the crummy slope, the average rate of change between these 2 points. So I'm going to say y minus y over x minus x. And right now this is just your geometry slope. Now I'm going to take a limit, and I don't want this point to be way over here. I want to move this point closer. In fact, I'm trying to get to this point C. So I want to move this point closer and closer and closer. But since I didn't name the gap anything, I don't know how far apart they are. Sorry, my application just quit. I may have to log back on if it doesn't let me write on it. I think I'm okay. Let me find where I was. Okay, so what I want to do is move X closer and closer and closer and closer to C. And I didn't name H anything, and so what we do is we say we want to move X closer to C. Now, it doesn't matter really since you're subtracting which way I did it, as long as I was consistent, but we normally write it this way. F of X minus F of C over X minus C as X approaches C. X gets closer and closer to C. And so what we want is we want to know what's going on over here. So, sorry, my application keeps cutting out on me. So when I'm pausing, I'm just waiting for my tablet to reload. Okay, so here we are. We're going to do that to this one. Now we actually could do this with f of x plus h minus f of x over h also. But we were instructed to use this formula. On this one. Both of these formulas right here find you a derivative, but they're instructed to use what we call the alternate form. So I'm going to take the limit as x gets closer to c of y minus y over x minus x. Right, so I'm just going to literally fill it in. The limit as x approaches c of f of x minus f of c over x minus c. Alright, like we did a lot of times with square roots or things that were subtracted and verifying identities, I'm going to multiply by the conjugate. So I could even do it if this was sine x minus cosine x. A conjugate's really good because it throws us into a difference of squares. The conjugate is change the middle sign, and you could do it to the top or the bottom, whichever one you need. So here I have the limit as x approaches c. This gives me x plus 6. I get a big bunch of stuff here minus the same thing here, so it cancels. And then be careful with your minus sign here. You've got to subtract everything. So this is going to be minus c minus 6. I'm not going to multiply this stuff out because it wasn't what I was trying to fix, which means I'm waiting for something to cancel. So this is x minus c times the square root of x plus 6 plus the square root of c plus 6. And don't forget I still have the limit symbol out here. If I filled in c everywhere there's an x right now, I would just get 0 over 0. So that's why I continue to work on my limit. So the limit as x approaches c. These 6's cancel, and I have x minus c on the top, and x minus c times the square root of x plus 6, square root of c plus 6. These cancel, and now I can finally fill in c. Up until this point I would have gotten 0 on the top and bottom. If I fill in c for x, I get 2 of these on the bottom, 2 of these square roots of c plus 6. Things to notice. The square root of x plus 6 transformed would pick up at 1, 2, 3, 4, 5, at negative 6 and go like this. So my tangent lines, except for at negative 6, should always be positive. Notice these slopes are positive. As c or x gets bigger, these slopes get bigger. And it's also is undefined back here. There is no slope back here. And if you zoom in on this, you actually get a vertical tangent. This is really a steeper dip in than you realize. At -6, the bottom would be 0. So these are gives you the slope of the tangent line at any point. Sometimes once we get it, we actually write it like this with an x in it, if we're doing an f of x. So this is f prime of x. Okay, so let's see if I can move this stuff up so that I can use it for the rest of the problem. All right, so on this problem, I wanted to know what was going on at the point 3, 3. All right, and what I'm doing is we're finding the slope of the tangent line at that point. And so sometimes you'll have an x and a y, but right now I just have an x. And so f prime of 3, the slope at 3 is 1 over 2 square root of 3 plus 6, which is 1 over 2 times the square root of 9, which is 1 over 2 times 3, or 1 over 6. So let's look at our graph of the square root of x plus 6. And at 3, I do believe the slope would be very, very slowly up 1 over 6, the slope of the tangent line right there. Now later on it's going to want me to write the equation of the tangent line, and so I'm going to go ahead and do that on 45, even though it's not necessary. At this point we're through with 45. I want to actually get the equation of this line, then I'll graph it all on Desmos. So this is what's happening on Desmos. Let's put in the square root of x plus 6. Alright, and so I want the slope of the tangent line over here at 3 is what I was asked to do. And you can imagine it's up 1 over 6. It's like we did a good job. They could have asked me at any x that I fill into my derivative once I found it. Now I'm going to write the equation of the tangent line, and we'll put it right in here. Okay. Alright, so let me go back to my tablet. How would you write the equation of the tangent line at the point 3, 3? Alright, the equation of a line that I use is the point slope form. Y minus y equals m times x minus x. We use that form a lot in calculus. Now m is the slope of the tangent line, 1/6. And in fact in calculus you can leave it like that many times. I'm going to usually add the 3 to the other side. Y equals mx plus b sort of form. In fact, I usually really just leave it like that on my paper unless I'm doing multiple choice or something. If you wanted to really get y equals mx plus b form, you could now distribute and add. But I'm just going to leave it like that. We want to leave our answers in the purest form we can when we're allowed to. So I'm going to put in 1/6 and then I'm going to have x minus 3, and I had added the 3 to the other side. And you see that we get the equation for the tangent line at 3. I'm going to turn this one off for a minute because I think it's in our way, because I really wrote it exactly at 3 right there. And you see that's the equation of the tangent line at 3. And if we did it at another point, that tangent line would change. Alright, so now let's see what else we've got here. Let's do 44. Alright, so I'm copying down 44. And I won't write the whole equation of the tangent line right here. I'll just write the slope of the tangent line. So on 44 is all he asked me to find the slope at -2, 1. Alright, so you have f of x equals x cubed plus 2x squared plus 1. And we want it at this point. Now this is a very curvy graph, we think. X cubed plus 2x squared plus 1. Let's see if we can estimate what the slope of the tangent line is going to be there. X cubed plus 2x squared plus 1. Alright, so we have x cubed plus 2x squared plus 1. Is it plus 1? I just want to make sure I copy it down correctly. Yeah. Alright, so plus 1. Alright, so there's lots of different slopes here, and they're wanting us in this one to find the slope at the point negative 2, 1. So let's look at the slope at negative 2, 1. Let's see. I'll get rid of this because that's not indicative of what we're doing now. So the slope at negative 2, 1. Here's negative 2, 1. I'll see if I can land right on it. I missed, there it was, sorry. Here, I'll label it at negative 2, 1. Okay, so the slope should be a very steep, a pretty steep positive number right there at negative 2, 1. So let's see what we get. Alright, we could use either form, f of x plus h minus f of x over h, and take the limit as the gap closes. Or we would have to use a form they're asking us to, f of x minus f of c over x minus c, and take the limit as x gets closer to c. They've told us on our summer work to use this one. And so if you're doing this one, lots of times things collapse and your x's cancel out, and then you can fill in, factor and cancel and fill in some h, fill in 0 for h. And this one you're usually doing some sort of factoring by grouping or conjugate work. Alright, so I'm going to have the limit as x approaches c of f of x minus f of c over x minus c. So this is f of x, this is f of c, and then I'm going to distribute my negative sign, and I do factor by grouping, which I don't normally do. This is x cubed minus c cubed. This is 2x squared minus 2c squared. And I have 1 minus 1, which cancels, over x minus c. If you fill in c for x, or x for c, you'll get 0 over 0. To remind you how to factor a difference of cubes. Then I'm going to factor this, and I'm going to leave this alone. Alright, so usually I factor by grouping in this alternate form. You may not remember how to factor a difference of cubes. You don't do it very often, but you figure out what you cubed, and you square the front, put it in the front, square the back, put it in the back. You multiply these two numbers together and put it in the middle. And the last sign's always plus when you're factoring sum or difference of cubes. Since this is minus, it'll go minus plus. This I'm going to rewrite into x plus c, x minus c. Alright, so now I see that they all have an x minus c in them, so I probably should factor this to the outside, here and here, but I'm just going to go in and cancel them out. The x minus c's, they share it. And so now I have the limit as x approaches c, so I can go ahead and fill in x is getting closer and closer to c, so where there's an x, I'm going to put in a c. I get c squared plus c times c, c squared, my x is becoming c's, plus c squared, plus 2, c plus c, x is becoming c, getting closer to c, so you get 2 times 2c. And so that gives me 3c squareds plus 4c. A lot of times we like to do it in terms of x, depending on what we've been asked to do, because they've really slammed into each other and you can't tell one from the other. So, I'm sorry, I would do 3x squared plus 4x. Either one of these is acceptable. You can use whatever variable you want. This is an f prime of c. This is an f prime of x. And they wanted me to find it at the point -2, 1. Alright, so I'm going to find f prime of -2. Right now I only have an x to fill in. And let's fill in -2. So it gives me 3 times 4 minus 8 equals 4. Remember we said it would be a really steep slope right there. Like up 4 over 1 is happening right here. And a lot of times we write so we're through with this problem. A lot of times we write the equation of the tangent line though so we can actually see it. So I could go in and write the equation of the tangent line here by saying y minus that point 1, y minus y equals m, which our slope was 4, times x minus x minus -2, trying to lock it onto that exact point, and that's the equation of the tangent line. Alright, now, which I took it a little further. But I did that to help you because it asks you to write the equation of the whole entire tangent line of 47 and 48. So first of all, you've got to find the derivative and then answer the question. Now, here's 47 and 48 are a bit different in that you've got to remember what parallel and perpendicular mean. Here, you want the equation of the line, that equation of a line that is tangent to the curve of f of x equals x cubed, and it's parallel to this line. So you find the slope of this line. In fact, let's do 47. 47. So you have f of x is equal to x cubed, and we want to be parallel to 12x minus y plus 10 equals 0. Alright, so I've written it on my whiteboard here, and we'll be doing 47 also to help you. Okay, so let's get a graph of what we're trying to do first. I'm going to solve this for y. Y is equal to 12x plus 10, or I can reverse it. Okay, so y is equal to 12x plus 10. Let's make sure I copied it down right. Alright, it's going to be really steep. So there's some line that is y is equal to 12x plus 10. And my equation is just x cubed. And I'm trying to write the equation. There's some tangent line or tangent lines that are parallel to this one. In fact, it looks like there could be one back here and maybe one over here. So let's see how many that we find. Alright, what does parallel mean? Parallel means that we want to have the same slope. Okay, lines that have the same slope. So we're looking for a slope of 12. Alright, so there's kids playing outside that you can hear, probably on this video. Alright, I'm going to use the x plus h, f of x plus h minus f of x over h, and take the limit as h approaches 0. Sorry about those kids. Alright, so anyway, I'm going to go x plus x cubed minus x cubed over h. I'm going to put in x plus h and x. Oh, I'm sorry, you couldn't see what I was doing. I was distracted by the kids outside. So let me say what I was saying. I'm so sorry. Here's the problem 47. We want it parallel, which means we want the same slope. And so I solved for y, and I know the slope of this is 12, so I want to force my slope to be 12. Okay, so I'm going to find the slope of the tangent line and force it to be parallel, and so I want to know what x coordinate or coordinates that happens. Alright, so now I'm doing the binomial theorem. Okay, so you can ask me questions about this later. This is doing this to the third power, 3xh squared plus h cubed minus x cubed over h. Alright, this collapses. I don't have to do that canceling. And everything has an h in it. So I have the limit as h approaches 0 Hang on, I'll close the window and see if it's quieter. I don't know if you could hear all of that going on outside, but anyway. All right, so now everything else has an h in it, so I'm going to factor out the h and get 3x squared plus 3xh plus h squared over h. Now I don't get 0 over 0 anymore that I had up until this point, and now when h approaches 0, these two go away, and I'm left with 3x squared. This is the slope of the tangent line. Like for instance, x cubed looks like this. When x is 0, the slope will be 0. But at some point when x is something, I can force it to be 12. So I'm going to set my slopes equal to each other because it said parallel. You have one to do that's perpendicular, so be careful. So this is the slope of the tangent line at any point, and it varies, and I want to know when it hits 12. So I get x squared is equal to 4, so x is plus or minus 2. Alright, so it happens when x is 2. Now I'm supposed to write the equation of the entire tangent line when that happens. And so, I know when x is 2, back up on my original graph, which was x cubed. When x is 2, I get 8. And when x is negative 2, I get negative 8. It happened twice. It was equal to 12 way back here and way over here. Alright, so I'm going to write the equation of my tangent line. Y minus y equals m times x minus x for this one. And for this one, I'm going to have y minus y equals m times x minus x. And what do we do for the slope? We know at 2 and negative 2, the slope is 12. Okay, so that's the answer to 47. Let me type them in so you can see visually. I'll give you lots of pictures of how things happen. So I'm going to put in y minus 8 equals 12 times x minus x. Oh, I need equals. Okay, and so we have a slope of a tangent line that's 12 at 2, 8. Let me lock onto that. Alright, so at 2, 8, I have that really steep slope of a tangent line. And then at negative 2, negative 8, it happens again. I should have that slope for that moment again. And so, write the equation of another line. I have y minus y minus y and x minus x. And these are what was asked of, parallel to 12x minus y plus 10. These are parallel to 12x minus y plus 10 equals 0. You see how those are all parallel. So one thing you want to learn in calculus, I'll say it to you a ton, is be very literal. Be very literal about your work that you do. So I just went through their commands. Find an equation of a line that is tangent to the curve and it's parallel. So first I dealt with parallel. I found the slope. And I know now that the derivative gives me the slope of the tangent line. So I set that slope equal to the derivative and figured it out from there.